Okay, let's go. All right. Oh my God, this word. Lexicographically, smallest string after applying operations. Medium. Given a string S of even length consisting of digits from 0 to 9 and two integers A and B, you can apply either of the following two operations any number of times in any order on S. In any order. Okay. Add A to all odd indices of S. Digits post 9 are cycled back to 0. For example, if S is 3, 4, 5, 6, and A is 5, then you can change you can add, right? You can add A to all odd indices. So the 3 and the 6 gets added with 5, and you get 3, 9, 5, and then the 6 becomes 11, kind of mod 10, so it becomes 1. And rotate S to the right by B positions. For example, if S equals 3, 4, 5, 6, and B equals 1, S becomes 3, 6, 6, 3, 4, 5. So the 6 moves to the right, and then it cycles to the front. Return the lexicographically smallest string you can obtain by applying the above operations any number of times. Okay. Well, interesting. A string is lexicographically smaller than string B if in the first position where A and B differ, string A has a letter that appears earlier in the alphabet. So 5, 5, 2, 5, A is 9, B is 2. A is 9 means you can make the 5s into 4s. Technically you can make them into any number because you can just cycle enough times to make them into like both 4s, both 3s, both 2s, both 1, both 0. So I assume you want to cycle so they're both 0. And then probably move it down so that the 0, it's 0, 2, 0, 5. Why wouldn't you move it down further? B, you can move B, oh, B is not 1, I see. B is 2, so you can move it down 2. So it's either 2, 0, 5, 0 or 5, 0, 2, 0. Okay. Interesting. And since this is even length, it's even length string. B is 1, so that means you can go through any starting point. A is 5, so you can only do 74 or 79. Oh, I see. They cycled it down 1, made it 47, changed it to 42, then cycled again, so it's 24. Alright, well this is pretty rough. Not gonna lie, this is pretty rough. Let's see. I think if I want to say if the length of the string and B are relatively prime is the relationship, then you can choose any any kind of correctly spaced digits within the string to perform the first operation on. But if they're not relatively prime, then only certain placements can ever be at the front, and therefore only certain placements can ever be changed with the first operation. If because 1 is relatively prime with any length string, any even length string, or any length string, then this pretty much guarantees that you can always change. No, let's see, yeah. Because you can change the odd digits. So, okay, you can change all the odd digits. And if I'm dealing with a relatively prime b and length of the string, then the odd digits could be rotated so that they're where the even digits are. Yeah, so I think pretty sure if b and length of string are relatively prime, then possible to rotate, which is second operation, such that the even indices and odd indices swap, and thus the first operation, which is to add a to all odd indices, first operation can be applied to either all odd indices or all even indices. I'm pretty sure that's right. So if b was, let's say, 4, what does that mean? B is 4. Okay, so I mean, since it's an even length, then yeah, so I think furthermore, b and length of s are relatively prime if and only if b is odd. Since ln of s is stated to be even. Yeah, I think that's right. Okay, so b is 2. If b is a certain value, actually I think if b is odd, then any index can be rotated to be the starting index. Pretty sure that's right. But if it's an even value for b, then I don't think that's true. Because if b was the exact same value as the length of the string, then rotating will only is definitely not true for b is even. Example, if b is 4 and length of string is 4, then rotation, then second operation, rotation doesn't change the string. Doesn't change the string. So I guess the question might be, what would, so the only case that I'm unsure about in this area would be what, based on the length of the string and the value of some even value b, what would be the indices that you can actually rotate such that that indice would be the start. I guess maybe you could okay, so let's say length of the string is 10, b is 2, then any even index could be start, right? If the length of the string is, let's say, 10 and b is 4, I think that also is true. Any even index could be the start. Okay. I guess this is wrong then, actually. This is wrong. This is wrong. If b is a factor of the length of the length of the string, then there is no kind of offset that you can make. So the start of the string is some multiple of b in that case, and that's a very finite set. If b is odd, this is false. What am I thinking about then? If b is odd and they're relatively prime, now furthermore, actually, relatively prime. Yeah, okay. Yeah, that's definitely true. This is wrong. They're not relatively prime if they're only if b is false odd. Furthermore, being relative prime if and only if only, I think it's maybe if these are relatively prime, then b must be odd. That's not the other way around. If b is odd, doesn't necessarily mean they're relatively prime, because then they could, the length of the string could be 10 and the b could be 5. Yeah. If b is odd, this is wrong. I think I think if b is odd, yeah, okay. So if b is odd, then second operation can swap all even or all odd indices. That's true. If b and the length of the string are relatively prime, any index can be chosen to be the starting index through rotation. Oh, this is, if b is odd, the first operation. What else? If b is odd, b equals the length of the string. If b equals the length of the string. Okay, so I need to know which indices can be the start. And so so I think it's going to be if if uh, if I have, let's see, be equal to the greatest common factor of b and length of s, the greatest common factor, then any multiple of c can be starting index, I think. Yeah, I feel like that might be right. So if this is 10 and 4, the greatest common factor between those is 2, then any multiple of 2. If it's 10 and 5, the greatest common factor would be 5. Is b always guaranteed to be smaller than length? B can be equal to length minus 1. So so it's never going to be a trivial thing where b is equal to length. But it's never a trivial thing. Okay, that's fine. That's fine. I think this is right. So that even works if if b is 1, right? Greatest common factor between 1 and any number is going to be 1. And so any multiple of 1, which is any number, can be the start index. Okay, yeah, I think this is right. Okay. Okay, so question then is, what would be the What would be the best way to handle this? So I can determine what my starting positions are. I can determine what values I can change. Okay, so let me go and just create a convert the string to array of integers, array of digit integers. So I think that's going to be, let's say digits is a list based on mapping the string, every character into a string into an integer of k. Is that right? I think it's actually mapped to int, something like that. Always unsure about my syntax. Let's see. Is it the other way around? Is it the... Yeah, okay. I think it's int and then the string. Okay, so this thing converts to 5525 740011. Okay. And then let's go ahead and create a Boolean, let's see, even, maybe cycle even. I'll say even okay. Is true if first operation can be on any even index. So this is going to be true if b is odd. Okay, so even okay is, I think I can just do a Boolean expression here. I guess it's b mod 2 equals 1. So there I can swap either any even index or any odd index. And then lastly, the indices that can be the starting index. Okay, I guess I'll do start indices is an array, and I think it's going to be, let's see, let's say C is the greatest common factor, or maybe F, maybe common, is GCF of B in the length of S, and then it's every multiple of this, right? So it would be something like, so if I have like common is 2 and length is 10. I need to add every value that's, I think it's probably something like, I'll try to do a list comprehension, I guess. Start indices is k times common for every k in range of length of s divided by common. I think that's right. Greatest common factor. Greatest common divisor. GCD. No, is it the GCD? Greatest common divisor? Yeah, I think that's probably right. Alright, let's do a test case here. Let's say the test case is 10 and 4, I guess. So 10 length string, 4 length B. So this should give me 0, 2, 4, 6, 8 as the starting indices. And then if it was, let's say, 5 for B, this should just give me 0 and 5. And if it was, let's say something that's relatively prime with 10 less, so let's say 7. This should give me 0 through 9 for the start indices. Okay, I think that's right. Okay. So now comes the actual hard part, I think, which is how, so I know where I can start from. I know which indices I can affect. And if I can only start from certain indices, like let's say every even, then I'm pretty sure that I can only affect the the odd indices. I don't think I can affect the even indices in that case. Huh. So how would I approach something like this? So I'll say print and change evens. Okay. Print where it can start. So I can only change the odd indices here, and I can only start at indices 0 and 2. can change evens. I can change the evens here. So I can change, wait, really? Okay, yeah. It was possible to make this into a 79, but it didn't make sense to change the 4 into a 9. So therefore it just kept it. So it was either like make this into a 2. Yeah, it would make sense to make this into a 2. I guess maybe because normally I can change the odd indices, that's a given. So I could change the even indices here. I cannot change the even indices here, so I can only change the 0 and the 1. But you wouldn't really want to. And you can start as either 0 or 2, so it's either 1 1 0 0 or 0 0 0 1 1. Okay. Actually, now that I think about it, it has to change all the indices at the same time, I guess. By any number of times in any order on S. Add A to all odd indices. Yeah, so you can't modify individual indices. You have to modify the set of all evens or the set of all odd indices. The numbers at those values. Interesting. What would make sense? Also, I think here it's actually a pretty finite array or string. It's only 100 characters. Do-do-do-do. So in theory, what? In theory, for any starting index, you want to make that into a 0 if possible, right? You want to make the starting index into the lowest possible value that you can. And that's going to be some number of operations, first operations. And that's going to be fixed in terms of if that's the starting index, that's the number of operations that are going to be performed on every odd or even indices if that's possible. So for every starting index, and determine the correct number of operations of first operations, adding a, in order to minimize the string that would be formed. Starting at the index, obviously starting at the index, based on looking at the first or second digits in that sequence. Right, because either your starting index is on a spot where you can actually modify, or it's on, or if it's not on a spot that you can modify, then the next digit should be on a spot that you modify, and so you minimize based on whatever makes that the smallest possible digit. So like the 74 here, the starting digits the 74 here, you can start at either 0 or 1. So if you start at 7, then you would need to, and since you can change all indices here, then you would modify this to become a 2. And because you modified this, then obviously, if there are more digits, then they would change, but the 4 would obviously be the same. Because 24 is the lowest number that you can get when 0 is the starting digit or starting index. And then if 4 was the starting index, then 4 and 4 you could change. You could make that into a 9. That wouldn't be helpful. And if you didn't modify that, then you'd probably you might modify the 7 to make it 2. So that'd be 42 is the other kind of lowest number possible. So here you can either start with 0 or 2. So if you start 2, 5 would need to be modified to make it lower, to make it 0, because A can do that. So that would make it 0. That would be, you need to do 6, 7, 8, 9, 0. You need to do 5 operations. Well, yeah, 5 plus 5. 5 minus 5. Each operation lowers it by 1. And so that would make this into a 7. So it'd be like 0, 5, 7, 5. So that's the lowest you can get it if you actually wait. This one you can start at 0, but you can only modify the odd indices. So you can only modify the 5s here. So yeah, so it says 5020 or 2050. All right, let's do something that's not trivial here. Let's do something that's kind of brand new. Let's do pi, I guess, 31459. Let's say A is 2 and B is, let's say B is 3. So you can start index 0 or 3. You can change all indices. Is that true? So if you kept it the same here, then you can modify 159. If you rotate it, then you can modify the other ones. And then you can rotate it again. Yeah, that's true actually. So it doesn't really matter considering the order of operations. It's just the end result is going to be you can modify any even or odd indices, and you can start at any 0 or 3. So if I start at the 0 index, I want to make this into a 1 by basically subtracting 2 to all the even indices. So this would be 1, 1, 3, 1, 4, 5, 1, 9. So if I subtract 2 from all the even indices, it would be 1, 1, 2, 5, 9, 9. And if I did the rotation, so I start with 5, 1, 9, 3, 1, 4. Here I would subtract 4 from all the even indices, so it'd be 1, 1, 5, 3, 6. No, subtract 4. 3, 7, 4. So it should be, the answer should be 1, 1, 2, 5, 9, 9. Interesting. Okay. I think I should probably do one more just to make sure that my logic is correct here. Let's say it was 9, 9, 2, 1, 5, 7, 8, 3. Okay, so this one is 7 characters. I should probably be able to... this is going to give me a lot of options. Let's do 8 characters. Let's say B is 6 and A is, let's say, 5. So it should be able to start at every even indice. Yeah. And here I can only change the odd indices. Okay. So 9, 2, 1, 5, 7, 8, 3, 4. So if I start at index 0, and considering that it's subtracting 5, that means I can only modify it by subtracting 5 or adding, or it's either going to be that number or the number that's like 5 away from it. So the lowest this could be like is doing one operation, which makes 9 to 4. So it'd be 4, 2, 6, 5, 2, 8, 3, 9. Alright, so then if I rotate it and start with the second index, it'd be 1, 5, 7, 8, 3, 4, 9, 2. This is already as low as it goes. So this is, yeah, there's no operation there. And then starting with the fourth index, or index 4, it'd be the 7, so it'd be 7, 8, 3, 4, 9, 2, 1, 5. Here you definitely make the operation change to be, it'd be 2, 8, 3, 9, 9, 7, 1, 0. And then if I start with the 3, 4, 9, 2, 1, 5, 7, I'm missing one. 3, 4, 9, 2, 5, 7, 8. So that one stays the same because 3 is only going to get bigger if I do operation on that. So the smallest one should be this. Oh boy. 1, 0. Where'd that come from? One zero. Oh my god. I'm thinking of my even and odd indices incorrectly. Fuck me. Whoops. Odd indices are the 2, 5. Okay, so sorry. So this should stay the same because the 2 can only get bigger. And this one should change because the 5 can get smaller. So it'd be 1, 0, 5, 1, 0, 7, 3, 3, 9, 9, 7. 1, 0, 3, 3, 9, 9, 7. Okay, yeah. And this one technically would get smaller to become 7, 3, 3, 4. 9 becomes 7, 3, 3, 9, 9, 7, 1, 0. And then this last one, it would stay the same. Okay. So what's the play here? Is it possible that I have something where it's I can change both evens and odds and it's any starting point? Likely, right? Like if it's 10 and 3, the length is 10 and or 5 and 3 maybe. Let's say it's like 5, 5, 2, 6. Let's say, I think this should be that I can start with any index and change both either odd or evens. Oh shit. Okay, so that's not going to work. Let's say B is 5 here, so this means I should be able to start with any index. Yeah, I should start with any index and be able to change either odd or even. Yeah, so I can start with any index, change either odd or even here. So like 5, 5, 2, 5, 7, 6. So let's just write all the possible starting things. So it's like 5, rotate once. 5, 2, 5, 7, 6, 5. Rotate again, 2, 5, 7, 6, 5, 5. 5, 7, 6, 5, 5, 2, 7, 6, 5, 5, 2, 5, 6, 5, 5, 2, 5, 7. And here I change the 5 into a 1. So it would be 3. So in net would be minus 4 for all the even indices. So it'd be like 1, 5, minus 4 is 8, 5 minus 4 is 3, 6. Here, minus 4 would give me... Actually, why am I doing minus 4? I could do minus 5. So it'd be 0, 5, 7, 5, 2, 6. This is going to be 0, 2, 0, 7, 6, 0. This is going to be minus 2, so it'd be 0, 5, 5, 6, 3, 5. This minus 5, so it'd be 0, 7, 1, 0, 5, 7. No, I did that wrong. 1, 5, 0, 2. Minus 7 here. Minus 7 here would be 0, 6, 2, 5, 5, 5. Minus 6, 0, 5, 9, 2, 9, 7. So the small should be this one, 0, 2, 0, 7, 6, 0. Oh no. How did that even occur? That's so many zeros. Oh. It's because I can change both. I see. I can change both. So I can make it into... Actually, I don't see. I do not see this. It's 3 zeros. I think it should be this one. So how many times does it rotate here? I rotate once. So starting here is 5, 2, 5, 6, 5, 5, 5, 2, 5, 5, 2, 5, 7, 6, 5. Oh, I subtracted wrong. Okay. And then I could change the 2 to make that into 0. So it'd be 0, 0, 0, 5, 1, 3. Okay, I didn't catch that. I was only thinking I could change either the odd or the evens, but this one I can change literally everything. Huh, change literally everything. Yeah. I wonder if I can separate into 2 separate parts. Like if I consider the odd indices as one sequence and the even indices another sequence, if I can change both odds and evens, then really it's going to be the what I would get. No, that's not true. Not true. It would be some version of starting at a certain index and finding the kind of concatenation or the intertwining of the lowest sequence of odds and evens from that index, from that starting index. I guess that is true. So if I can change any index, can I treat them as independent? Kind of. Start any index and change only the odds. And the evens, or only only odds. The evens don't matter. Oh my god. Small string after point operations. So I should be able to look at just the first two. So let's see. I need to think about how much I can modify a particular digit. I think it's like if it's an odd value of A, then I can change the digit into any number. You can modify it by any number cycle to make it kind of lower. So you can subtract 5 by 5. But if A is an even number, no, that's not true. I guess it's odd that's not 5. I should be able to change it to be any number. If it's odd that is 5, then it can only be that number or that number plus 5. And then if it's an even number, then you can change it by any even amount. So if it's like, you can add 2 or 4 or 6 or any. Actually, A is only a number between 0 and 9, right? Yeah. So if it's an even number, then it can become, you have to subtract an even amount. If it's an odd number, not 5, then you can subtract any. Okay. Okay. I might do a big if statement for the values of A. Okay. So the starting index is either going to be the starting index maybe it should be Boolean even okay is true if first operation can be performed. Maybe I can do Boolean only odd. I think that would be something like or if your starting indices were only like, let's say 0 and 5 and your length of the string is 10, but in that case b is odd. In that case b is odd, so only odd is true if your first operation component. So this should be b mod 2 is not equal to 1. Is that right? So if you're dealing with if the even is okay, no, sorry. So if you're dealing with an even value b, then you should only be able to modify the odd indices and never the even indices. If you're dealing with an even value b, yeah, I think that's fine. So here I can change any indice. I think I did that one. So yeah, I can only change the, yeah, I'm pretty sure I did the one. The 1, 0, 7, 3. Okay. Okay. Convert the string. So I think maybe if the string is string is 2 length at least. String is at least 2 length. Okay. String. I need to do something like I need to decompose this. Modifications. Modify is going to be an array. N is the length of the string. For every start in start indices, I need to figure out what the correct offset is for those things. What the correct offset to change the first and second values in the string. Okay. So let's say that the string starts in something is odd or not. So if the start is odd, well, maybe it should be is even. If the start is even, so I should be able to modify the start if, as long as it's uneven, or no, sorry, I should modify the starting spot as long as the starting spot's odd at all times, or if it's not only odd, right? If it's an odd start, then obviously I can modify it. If it's an even start, then I can modify if it's not only odd. So actually, maybe I should make this as even. All right, I'll make it. I'll maybe eventually figure out which one I actually want to use. If the start is odd, or I can modify both odd and even indices, then here I need to figure out what the correct modification is. Say mod first equals mod second. Mod here is just modify, not like the modulo operator. Although it's kind of similar in some ways. If it's odd or not only odd, I think I need I need to know what the value, how A can affect it. So if A is even, then I can only change by an even amount, in which case it becomes that number mod 1 or mod 2, the remainder of that number by 2. And if it's 5, if A is 5, then I can only add or subtract 5, or if A is anything, then or any other value like an odd number that's not 5, then I can subtract whatever the value is at the start index. So trying to figure out how to set the variables here. A even is A mod 2 equals 0. a, I guess that's it. Really. If a even, then mod first should equal whatever the start value is. Indices at start, mod first should be start val minus start val mod 2. So if it's like 7, then 7 minus 1. Yeah. I think that's fine. Else, if a equals 5, then mod first equals the smaller of this start value and start value plus 5 mod 10. Else, this is an odd number that's not 5, then mod first should equal start value. Okay, and then mod second. So actually, I need to do the bigger else. If it's odd, I can modify it. Or if the starting index is not, or if the starting index is an even index and I can modify even indices. Okay, I think this is right. I think that covers all the bases. And then I think I need to do something for the second spot after start val. If the start value is on an even index, then I should be able to modify the value after it. So not is odd, or not only even, not only odd. So that means I should be able to modify. So not is odd means that it starts on an even. So if it's even, then I can change the value after it. Or I can change all values. Because it started on odd, I can change all. Okay. Yeah. So here, if a is even, then the mod to the second number is going to be start value minus start value. Oh no. Let's say after value is start indices at start plus 1. After value is equal to mod second is going to be after value minus after value mod 2, else if a equals 5, mod second is equal to the minimum of after value and after value plus 5 mod 10. Otherwise, after value is going to be affected by whatever it is. So this is all subtraction. No, that's not true. This is not correct. So the first and the last are subtraction. This is setting it to a certain value. I guess here, if a is 5, then I either subtract 5 or I don't. So I guess this should be mod first should equal 0 if the start value is less than 5. Else it should be 5. You either subtract 0 or 5, yeah. Zero if the after value is less than 5, else it is 5. Okay. Guess I didn't need the is even. Okay, so then what I want is I want to do the modify, append the tuple that is these two things that I calculated. So for every starting index that I know that it can rotate to, I calculated how much I can change the start value by and the after value by, starting with that start. So the start mod first is what affects the indices on the same parity as the start index, and then mod second affects the values at indices that are not the start index parity, and the modification is subtracting this number from that value, and then doing mod 10 if necessary. Okay. So then what? So then I need to iterate over all possible start indices and track the best, I guess. Track the best first two, and then if there's a tie, then track the best second two somehow. All right. I guess maybe. Okay, I think I have an idea. Say min value is 100. Min value is going to be the value that is formed from the first value that was formed from the first ones, I guess. Something like that. I'm not describing this very well. Okay, so let's say parts is equal to n divided by 2. So if I were to treat each part separately, like the 0th part, or the first part, the second part, where the first part is defined at start index and start index plus 1, the second part is start index plus 2, start index plus 3, then I can compare, I can identify what the lowest part value is, like what the lowest two-digit combination is. And if there's a tie, then I keep track of all the start indices that are tied. Yeah, okay. So for every pin in the range of parts, so pin is going to be like the first part is going to be start index and start index plus 1. The second part is going to be start index plus 2, start index plus 3. So pin is just the part index. So for all pins, and then for the min value is going to be tracked, which is the two-digit combination from that part. And then let's say the min, I think I need to have a list here. I think I'll say possible is whatever was the start indices. Okay, so next possible is going to be an empty array, and this is the next possible low start indices to consider on the next iteration. And like eventually it'd be if the length of this is equal to 1, then return something. Return whatever string would be created from that. Return string created by that possibility. So the possible is the start indices. So for every, and actually here, else the possible is equal to the next possible. So for every start in the possible set, I need to identify what the values are at the pin modified locations. So it should be I'll say V1 and V2 are the digits at pin times 2 plus this starting index mod n, I think, because I wanted to wrap around, and then digits at pin times 2 plus start plus 1 mod n. I think that's right. And then I'll say D1 is for every start impossible. Huh. I need to keep track of the modification. I guess maybe I can do possibility is the index and then the modifications at the index. So I can do, like, let's say possibility is modification of the start index, how much you modify the first and the second indices. Okay. So the first digit would be v1 minus mod the first, and take this modulo 10. v2 is going to be v2 minus mod the second. And then the actual value, the combination of those two is going to be d1 times 10 plus d2. Maybe I can call this min combo. If combo is less than the minimum combo, then the next possible should equal this tuple. That is this start, this mod first, this mod second. Else, if it matches the minimum combo, so that means there's a tie, then the next possible should append. Actually, maybe, I wonder if tuples are actually let's say os tuple. So I guess I don't modify at all. Okay. I think that's right. I guess here I can just say break, and then I'll figure out what I do after that. So this goes through all the possible tuples, modifying them, comparing those combinations till it finds a pair that's the lowest. Without any ties. I guess in theory there could be a tie at the end, in which case it is what it is. Like I'll just use the first element of the next pos. I'm pretty sure next pos is going to be something. Okay. So here it's going to be for every pin in range of parts. I'll just do an answer array, answer digits. I'll do an answer array. And then for every pin and parts, I wonder if I can just do this more simply, right? Because I know the tuple, the best tuple. So like it's gonna be start mod first, mod second is whatever this next possible 0. So I guess I could just do something like what would I do? What would I do here? Almost at the finish line for this code to test. So if I have my start, then I guess I could just do for every index in range n, I could do for every index, or let's say offset in range n, and then I'm going to add 2 values to my answer array. It's going to be at start plus offset and start plus offset plus 1. So I guess it'd be something like answer. Okay, so let's say value 1 is equal to, it's going to be a pretty nasty looking expression here. So I think it's digits at start plus offset mod n, and the value needs to be modified by mod first. So that digit minus mod first and then mod 10. Value 2 is going to be digits at start plus offset plus 1 mod n, whatever that is, minus mod second mod 10, and then answer append val 1, answer append val 2, and return the string join. I think it's answer to string, string to answer. Join map to a string the digits. Okay. List out of range. Line 25. I was pretty sure that this was not going to go out of bounds. Because the start indices... Oh, I see. Yeah, never mind. That definitely can go out of bounds. Oh boy. Okay. Yeah, that's my bad. How is it going out of bounds at the start index? 0 and 2. Oh, whoops, this would be digits. All right. Oh, that didn't work very well. Okay. By didn't work very well, as in it didn't work at all. I don't think this ended up being 1. No, I guess it did end up. Whoops. Next possible. Yeah, that's not. No, actually, 105. Starting at index 1. That's not good. Okay, let's go ahead and check out what is possible, since that is really what is driving it. So 0, starting at index 0, subtract 5 from that, that makes it 20. That makes this a 2. Subtract 0 from the 4, so that's 24. Starting index 1, so that's the 4. Subtract 0 from that, and then subtract 2 from there. So this is correct in terms of what I expected. Okay, so then for every, okay, let's go ahead and just print out what the combo is here. Oh, whoops, this is wrong. Okay, so it's 24 versus 42, which is correct. So 24 should be the smaller one. So it should have put pos tuple to be 1. Oh my god, I'm so stupid. I forgot to actually set the min combo. Okay. That's so dumb. Okay, so it ended up with 24. How did it add a 97 to this? What? For every offset. Oh my god. This should be offset divided by 2. Should be every offset It should be up by 2. So I think it should be 0 to n by 2. Oh my lord. Okay. Holy shit. Oh my god. Oh my god. Thank the Lord. That was a lot of stuff. That was just a lot of stuff. Every time I see something that is like so hard mentally, and then I finally reach the end. It's like, I don't even know. I don't even know. My mind blanks out. It's really just kind of, I'm not sure what I'm trying to say. There's just some relief that I actually was able to do it. There was like some sort of satisfaction that what I did was somewhat correct. There's just like 99% of the time that I spend on it, it's just in this state of confusion and uncertainty, and it's like, I don't know, it's not very satisfying. I guess there are problems where I kind of know, have a clear idea what the answer should be or how to get to the answer, and it's like just execution of the idea. But then there's stuff like this where it's like I literally am just coming up with random ideas and trying to make random stuff stick to the wall. Anyways, okay. And this is, I don't even know. I feel like there's a lot of ways I could possibly have done this better. I don't know, but all right, convert the string to an array of digits. Boolean only odd is true if the first operation only formed on only odd indices. Otherwise, if false, first operation can be formed, can be on any indices. Possible starting indices is based on relative primeness of the length of the string in B, and then find the possible starting indices based on the rotations. If A is even, let's say here, A value, A parameter value. Affects how much the digits can change. So for example, if A is even, digit 7 can become 1. Subtract 6 to all indices of that parity. So all even or odd indices. I guess that could be an example. Example, if A equals 5, digit 7 can become 2 or 7. And then example, if A equals non-5 odd, digit 7 can become 0. Subtract 7 to all to indices. Because I get minus. Okay. Possible, this is going to be tuples of start index, subtract first index, subtract A or digit at S or at start, and then subtract digit at start plus 1. So whatever that subtraction value is for every start and start indices, assume that the modifier for those is going to be 0 for those indices. Calculate what the start value are at those indices. Oh, I can, if I had a mind to, I think I would maybe remove some of these mod n and have digits be twice as long, or maybe append digits at 0 to digits so that I don't have to do mod n each time. Something like that. Yeah. A is even. Yeah. Determine modifier subtraction to first value. Determine modifier, which is the subtraction to the second value. And then add tuple to possibility array. And then this is going to be iterate over possibilities, finding the lowest for every part. Once a low possibility is found, break. So the number of parts is how many times you can split up the array into the digits into two digits. The combination is the 2-digit combination. The next possibilities is an empty array for every possible tuple. Start, first modification, second modification. The value, okay, I think this should just be two separate lines here. v1 equals this. v2 equals that. The digits after modification, combination, if the combination is low, then set it to that. If it's not the low, so this is reset the clear list and make new. Otherwise, I just add it to the combination. I guess maybe I could do something where I don't evaluate the first one. No, I have to evaluate to find the right combo value. Okay, if there's only one possibility, then that's the best one. Okay, I guess I don't need an else here. Otherwise, the possibility set is the next possibilities. And then you have your answer, construction. So based on lowest possibility. And then join, okay, yep. So, summary here, this is just kind of extremely complicated to summarize, especially the math. But let's see. In general, decomposed to certain variables, kind of flags. What's starting indices? Based on B and length of S are available after rotation. Which indices can be modified? Odd or evens, or odd and evens, based on A, based on B and length of S, I guess. No, it's only it's only based on B. Oddness with B. How much can any digit be modified, or given, or yeah, how much can any digit be modified based on A, and then iterate over all possible starting indices, and for each find create a list of tuples, start mod 1, mod 2, or modifier 1, modifier 2, where modifier 1 and modifier 2 are the values to subtract the initial 2 digits for a number starting at index start that would minimize that number. Or modifier are the values subtract the initial 2 digits. Those values would be fixed for the rest of the digits from there. So for instance, if you subtract 1 from the first digit and subtract 3 from the second digit, then every other digit after the first digit would be subtracting 1, and then every other digit after the second digit would be subtracting 3. So, and then finally iterate over all possibilities, over all tuples, finding the value, the 2-digit value at some part offset, where part offset is 0 to n divided by 2. To find the lowest part, to find the lowest possibility. So if you're dealing with the first part, then you go through all the starting indices and you see what 2 value combinations would be for the first 2 digits at every start index, given what you calculated were the correct modifiers to those things. If there's a tie and there's like a couple places where you can start with 0, 0, then you go to part 2. So you go offset, 2 from the start index, calculate what the 2-digit combination would be, and compare those. Eventually there should be one that is the lowest of all the possibilities. That should be the one that overall is going to be the lowest string. Lastly, construct the string, or the lowest digit string, based on the tuple that was lowest. So yeah, so this was creating the tuples, the possible tuples. This was finding the lowest possible tuple. Basically, you iterate over the parts that might be tied, and then find the next part that is the lowest. And then if you have a next part that's lowest, then therefore that possibility is going to be the best possibility. And then, so yeah, the next possibility is the lowest. Otherwise, you just iterate to the next possible set. And lastly, construct. Time complexity, this can be O of so I'm guessing it's O of n. No. It's like O of b times n, where the number of tuples that you need to deal with is based on b, and the number of possibilities is based on n. Yeah. Yeah. The length of the string. Yeah. Need to iterate over all possible tuples based on b, and compare them. And comparison would take O of n time, because it can iterate over the whole length of the string before it finds the break. And then space complexity, this should be O of b the number of tuples, or oven to create the string, create the digits array. Yeah. All right. Anyways.